Phil here, Félicien Legrand, US Sales Manager at GENTEC-EO. Thank you for the opportunity to present our latest releases at GENTEC-EO. So we call this presentation faster, smarter, tougher, new detectors for a new era of laser application. Laser evolve really fast, such as our offering for measuring them. Okay, quick overview of what we do here at GENTEC-EO. We've been around since the 1970s, providing beam profilers, power energy meters, and calibrated high power measurement for lasers. We are accredited ISO 17025, meaning that we do manage around calibration processes and manufacturing all on our own. We cover pretty much all industries, lasers, from consumer markets, medical, aesthetics, manufacturing, directed energy, scientific developments. We only provide absolute measurement capabilities with niche traceability with every standard and custom solutions that we deliver. Okay, so 3 parts for this quick presentation: faster, smarter, tougher. Okay, so we've released detectors providing higher repetition rates for measuring the energy, the pulse-to-pulse energy with pulse lasers. Smarter way to communicate those measurements from the probe itself to your PC, monitoring interfaces, tablet, smartphone, and so on, which is a really convenient way to measure. And then tougher. Year after year, we offer tougher absorbers to benefit from higher gamma thresholds in laser power density and laser energy densities. And I'm going to show you some of the latest releases for that matter. Okay, a quick overview of our energy detectors. So from the femtojoule level up to the multi-kilojoule level. First one, the photodiodes, from the femtojoule level up to, let's say, 100 nanojoules. This one is pretty low energy, low power. We offer that up to 1 kilohertz typically. The next one are the integrating spheres, so larger range in terms of energy from the picojoule level up to 20 millijoule typically. Repetition rate can be really high with those ones, up to 200 kilohertz in standard that we offer with the Max 6 series. And then we go to the pyroelectric detectors, which is the one with one of the largest dynamic range in terms of energy levels, and as well up to 10 kilohertz repetition rates, so fast repetition rates. This is one where we released new detectors, and I'm going to spend some time more in the next slides with the QE series here, the pyroelectric sensors. Keep in mind as well, for really high peak power density lasers, typically nuclear fusion projects, we offer single shot energy measurement capability with the calorimeters and the thermopiles. We've released calorimeters up to 16 kilojoules and counting. We innovate there a lot as well, and for taking really high peak power beams. Okay, so let's spend some more time on the QE series, the pyroelectric sensors. First, how does that work? Pyroelectricity, in a nutshell, that's a property of certain crystals to produce a state of electric polarity by a change of temperature. So the change of temperature is brought by the laser beam, the pulse of energy that comes out of the laser beam, the laser output. So you have a laser beam hitting the surface of this pyroelectric sensor. The heat is absorbed. Then naturally the crystal produces a voltage that's proportional to the amount of energy contained within the laser pulse. Then you have an ADC converting this analog signal to a digital signal going to the computer to provide a calibrated measurement. So this is a heat-based process. So it has some time and duration attached to this process. Long story short, the higher the energy is with your laser, and the slower the pyroelectric sensor is to produce a calibrated measurement. But one of the really good advantages of these technologies, it offers a really large dynamic range that we saw, from the microjoule level up to hundreds of joules. It is broadband as well, from the UV range up to 20 microns. This is really a flat kind of absorber that we use, so that easy to calibrate. The damage thresholds are pretty high, up to 16 joules per square centimeters. And the package is cost effective. You just need to take this detector and plug it into a monitoring interface such as a Maestro there, or a P-Link or a U-Link interface to get to your computer. Some of the challenges, once again, the response time, heat-based, so they can be pretty slow, and the repetition rate will typically it will be in the hundreds of hertz up to 1 kilohertz. So we spend a lot of effort to release new electronics and new crystals and a way to assemble those detectors, mainly for the QE12 and the QE25 detectors, so 12 millimeter squared and 25 millimeter squared detectors. First one with the MB absorber, which offer really high diameter thresholds in terms of energy density, up to 16 joules per square centimeter, and now comes up to 1 kilohertz capability. So 1000 hertz single pulse to pulse energy measurement capability. And with the MT absorber, the metallic one, which is faster by design, this one goes now up to 10 kilohertz. So good flexibility for measuring your laser pulse energies. And now with the new interface, the U-Link, to connect the probe to your computer. And this one captures every pulses up to 10 kilohertz to provide, once again, a calibrated measurement. Okay, next part, a smarter way to communicate. We've released for the average power measurement detectors, so the thermopiles, we've released wireless capability that we call the Blue, which is this little module attached to the probe, which gathers and processes the detector's data, connects via Bluetooth to your smartphone, tablet, PC, both Apple and Android, for the smartphone, to provide a calibrated measurement with the battery life up to 5 continuous days. And once again, not included, cost-effective package, no need to buy an additional monitoring solution with this. I mean, an interface. You go directly from the device to your PC, for example. Okay, and the new releases last year, we released the high power probes with the Blue capability. So that benefits a lot of the high power applications because you have no cable to manage. You can basically set your detector inside your safety enclosure, close the enclosure, run your measurement, and get the calibrated amount of watts to your monitoring devices. So it's safer to operate, no need to run a cable through feed through and everything. And that's once again one less instrument to carry, no interfacing box between the probe and the computer. Okay, so like I mentioned, the HP Blue series. So you have the module, the Bluetooth module that's embedded inside the casing. So slick design, operation up to 30 meters. You have as well the direct USB connection still, also available for using serial command for automating your measurement, for example. This series goes up to 15 kilowatt of laser power in standard and up to 16 kilowatt per square centimeter of laser power density. We do offer higher than that with a gold cone kind of absorber, not the flat one that you see here, with the wireless measurement capability as well. And as always, NIST traceability comes with these features. Okay, and then so tougher. Let's spend some more time on the diameter thresholds themselves in laser power density and laser energy densities. The new detectors we've released to use smaller beams or higher power, not a combination of two. Quick reminder, what is the diameter thresholds in the? So that's for power density and energy density in watt per square centimeter or joules per square centimeter. So the diameter thresholds in power density varies with the laser wavelength, the laser average power, the amount of heat that is brought by the laser beam, and the beam profile, whether that's Gaussian or flat top. If you have a Gaussian beam, the effective power density is doubled. So we need to take that into account when we release a product and to specify the diameter threshold. And by the way, the diameter threshold that we provide with in our specification, they are always listed for flat top beams. And you need to divide those diameter thresholds by 2 for Gaussian beams if you have Gaussian beam in your setup. And then for energy density, the diameter thresholds varies with wavelength, laser average power to the amount of heat, the beam profile, flat top or Gaussian or super Gaussian or combination, and then the repetition rate and the pulse duration. So this is all spec'd in our product documentation. Okay, so tougher laser power detectors, that's what we have released in the last couple of years. Integrating spheres, the new UPQD series, so thermopile detectors for measuring average power with volume absorbers, so really resilient technology to take high peak power pulse lasers. Then in addition to the pronto series, with higher diameter threshold for a handheld kind of measurement, you just place that inside of your engraving system, for example, and you get in 5 seconds a calibrated single shot power measurement. And then the HP Gold series with a reflective cone for up to 15 kilowatt, as we mentioned already. So quick overview. Technology for the integrating sphere. You have the integrating sphere coupled with a photodiode with a direct USB output. This is really good for integration of real-time inline power monitoring of laser system, because that goes up to 9 watts of laser average power, with the benefit of the high of the fast rise time of the photodiode, typically 200 milliseconds. So you can switch from laser to laser really fast and run your measurement quickly, with a high gamma threshold as well. It's 2 kilowatt per square centimeter in laser power density. Next one, the UPQD, really good for Q-switch lasers, manufacturing of high energy pulse lasers, really resilient technology. You see the numbers, to 100 kilowatt per square centimeter, tested up to 8 joule per square centimeter for 1064 nanometers, 10 hertz, 7 nanoseconds, and up to 300 watts in terms of average power. Next one, the Pronto 50W5. Once again, a really convenient tool to carry around your different lasers. This one is not actively cooled, so it takes up to it takes 5 seconds to produce an average power measurement. If it's above 5 second measurement, it has the capability to take some more, but you need to cool down the detector longer between shots. Feel free to share with us your laser specs, and we'll let you know which one in the Pronto series is best adapted for your needs. And yeah, what's unique about this one, now it goes up to 100 kilowatt per square centimeter of laser power density. So really tightly focused beams for measurement. And the last one here, so once again, the one with the gold cone, taking really high power densities and really high power levels, really good for fiber lasers, burning station, endurance test for hours or days for running a laser and see any variation in the output. In standard, we do offer many custom solutions, but in standard, off the shelf, we go up to 15 kilowatts, 80 kilowatt per square centimeter, and providing low back reflection down to even less than 1% back reflection, Lambertian profile with the tube option that you see on the right side of this of the slide here. All right, so I hope that was a good overview of our latest releases. We're constantly involving in releasing new products and injecting resources for releasing new products. So feel free to share about your application and how we can help with your laser specs. So go to our booth and let's share about your needs. All right. Thank you very much for your time.